Good evening, Titans. This is Mr. Simpson. This is lesson 7.1, factoring special products. First of all, we're going to look at the pattern for the difference of two squares. And if you recall, we've already worked with multiplying binomials that are identical except one is a sum and the other is a difference. Well, remember, now you're going to be given this, and you have to be able to come up with those two binomials. So in this example, it has x squared minus 9. And so what we have to look for is that we have to notice that the x squared is a perfect square and the 9 is a perfect square. So they rewrite it as x squared minus 3 squared. And now we know that it has to be x plus 3 times x minus 3. And those are the two binomials that multiply together to give me x squared minus 9. The difference of two squares patterns is pretty simple. And it's pretty easy to recognize because one, obviously it must be a difference, and then both terms must just be perfect squares. So if we look at these examples here, we have x squared minus 25. Well, x squared is a perfect square, and 25 is a perfect square. So we could rewrite that as x squared minus 5 squared, and now we just have x minus 5 times x plus 5. And now we're done. In letter B, 4z squared, well, that's actually 2z all to the second minus 1 to the second. So now my pattern is 2z minus 1 times 2z plus 1. Here they want you to use the pattern of a special product to find 54 squared minus 48 squared. Well, if we just take the concept that 54 squared minus 48 squared, well, we could rewrite it as 54 minus 48 times 54 plus 48. Well, 54 minus 48 is 6, and 54 plus 48 is 102. And now it might be a little easier to take 6 times 102. 6 times 100 is 600. 6 times 2 is 12, so that'd be 612. So that's just a way of using the pattern of special products. Not that we would use that very often, but just, again, showing you how we can use the pattern to do some mental math. So again, here are just a few more examples. And again, if you'd like to pause this for a moment and try to do these, then I'll reveal the answers in just a moment. All right, so for the first one, again, this is x minus 6 all to the second, x squared minus 6 squared all to the second, so then that's x minus 6 times x plus 6. Again, this isn't maybe a necessary step, but it does show that we have a term squared followed by another term squared. So in this case, 9n squared, well, that's a perfect square of 3n all to the second, and 16 is a perfect square of 4, so that's 4 squared. So now I have 3n minus 4 times 3n plus 4. And again, the reason it must be a minus and a plus so that the middle terms cancel out. Notice that there's only two terms, so the middle terms have to cancel out. And then here we'd have 36 minus 34 times 36 plus 34. Well, 36 minus 34 is 2, and 36 plus 34 is 70, and 2 times 70 is 140. And here we'd have 47 minus 44 times 47 plus 44. So 47 minus 44 is 3. 47 plus 44 is 91. And now we have 3 times 91, which would be 273. All right, now we're going to look at a different core concept of perfect square trinomials. Now here there's three pieces that have to always be true. The first term must be a perfect square, and the last term must be a perfect square. So those are the easy parts. The middle term must always be 2 times the square roots of those last two terms. Notice also that the last terms are always added. And then the other thing is if the middle term is positive, then the sign in the binomial is positive. If the middle term is negative, then the sign is negative. So if we look at the examples they give us here, we have x squared plus 6x plus 9. Well, x is squared, 3 is squared, and the middle term is 2 times x times 3. So now it's a perfect square trinomial, and I can write it as x plus 3 all to the second power. And again, the only thing that's different in the next one is that this is a minus, which means then that must be a minus there. So if we take a look here, we notice that n's a perfect square, or n squared is a perfect square, so that's n squared. 16 is a perfect square of 4 squared. And so now is the middle term 2 times n times 4? And it is, because 2 times n times 4 is 8n. So now I can just write this as n plus 4 all to the second power. This one, 4x squared is a perfect square because that's 2x all to the second. 9 is a perfect square because that's a perfect square of 3. And so now I have to check, is this 2 times the first term times that last term? And 2 times 2 is 4 times 3 is 12. So it works. So now it's 2x, and because this term was negative, minus 3 all to the second power. So a little bit more to special or perfect square trinomials than difference of 2 squared. So if we look at this one, this has 3 terms, so it looks like it could be a perfect square trinomial. Again, x is a perfect square, or x squared is a perfect square. 1/9 is a perfect square because it's 1/3 all to the second. And so then is the middle term 2 times x times 1/3. And 2 times 1/3 is 2/3 x. So that matches that middle term. So now I'm ready to write it as my binomial all to the second power. And letter B now is only 2 terms. So, and it's a difference of 2 perfect squares. So then I know that it has to be n squared minus 9 squared, which means it's just n minus 9 times n plus 9. Now, if I can't write it like this, then I'm not able to factor it into the 2 binomials. All right, and here's an application problem. A bird picks up a golf ball and drops it while flying. The function represents the height y in feet of the golf ball in t seconds after it is dropped. The ball hits the top of a 32-foot tall pine tree. After how many seconds does the ball hit the tree? Well, since the y represents the height, and we want to know when it hits this tree that's 32 feet tall, we're going to substitute in for y, 32, so we have 32 equals 81 minus 16t squared. So just like we've been doing, anytime we have a second degree, we want to set it equal to 0. So we're going to subtract 32 from each side. It gives me 0 equals 49 minus 16t squared. And now this is a difference of 2 perfect squares. It will factor into 7 minus 4t times 7 plus 4t. Notice I skipped that one step of rewriting it as each term squared. But now I just set each factor equal to 0, and I solve. So in this case, I have to subtract the 7, and that gives me negative 4t equals a negative 7. Divide by the negative 4. The 2 negatives go away, and I get a positive 7/4. Here, I subtract the 7 first, and that gives me 4t is equal to a negative 7. Divide by 4. And I get t equals a negative 7/4. Well, we're dealing with time. It doesn't make sense that time could be negative, so that doesn't work. But this one does work. So if t equals 7/4, so that's actually 1.75 seconds is how long it would take for that golf ball to hit the ground or hit the top of that pine tree after the bird had dropped it. All right, good evening, Titans, and hope everything went well. And remember the next slide here. Make sure we open our student journals to page 237 and complete problems 2, 10, 16, and 20. And we'll check these tomorrow in class.